So let's take that simple example of Ethereum, right? Now I have information on one chain that I need to get across to another chain. This is inherent sort of problem of cross-chain communication. So your node network, unless that they are running at least Ethereum clients, don't know what's happening on Ethereum. So how does your node network know what's happening on Ethereum, and how does the data actually get from your node network to Ethereum?
Right. These are the chains. They also are a full node on Supra, so they know what's going on here as well. And there's a large set of nodes that have to come to an agreement. So it's not a small set of nodes. It's a large set of nodes. At least 100 nodes, let's put it that way, for the bridge itself. Now, I want to make this clear that the Oracle model, our nodes are not all necessarily going to be registered as a bridge node. So if I'm a node and I just want to be a regular consensus node on Supra, you don't have to necessarily be a consensus node on Ethereum. You don't have to play that role of bridge on that. So it's a subset of nodes that have to participate on that. That is going to require different staking. That's going to require different kind of parameters and joining procedure. But I do want to, since you asked a really good question, by the way, I want to say you're throwing me some pretty decent hardballs, which is great because I love this stuff. And most people that interview us don't actually get this deep. So I'm actually enjoying this. This gives me an opportunity to share a little bit more about because we also have to think deeply about this stuff, right?
Right.
So, the bridge security itself, you're bound by the set of nodes for the bridge security. So in other oracles, you have a small set of nodes, and that's your oracle model. That's like the traditional old school model. You're bound by the security guarantees of a small cluster of nodes, not a network. In the bridging, similarly, same thing. You're bound by the security guarantee of the bridge nodes. So suppose you have 100 bridge nodes, and they all staked $100,000. That's $10 million. Okay? That's $10 million of bonded stake. The amount of value that's bridged between these networks should actually not exceed $10 million before it gets game theoretically unstable. Now, imagine these.
It's actually less than that, right?
Yes, exactly.
If you're a BFT algorithm, your security is only a third of that.
Exactly.
Depending on what your malicious actor assumptions are, but yeah.
Correct. So you want to keep that. And then I was actually going to make that point. It's actually more like half of that value. The moment you go beyond 5 million, you start to enter this territory of game theoretically unstable. Right. So that means only so little value can go back and forth, And so there needs to be some techniques and to kind of get beyond that. And we have a very interesting technique. It does involve multi-party computation, threshold cryptography, kind of things that run our protocol in general. And another kind of curveball, so to speak, that is not obvious. And we are going to be putting out that information in the months to come. But we have innovated the bridge model so we can go way beyond. We can go way beyond that 5 million threshold that we just talked about. But let's talk about
That's really cool.
Yeah. And I'm really excited about that. But let's talk about getting that data from our system to that system. Now, our bridge nodes, any of those nodes can post that data. And we will create the racing condition. Whoever's the fastest to post the data, they get the fee. So it's actually going to, and the data is being delivered with this cryptographic signature of our network. So it doesn't matter who delivers it, but because the smart contract is going to check the data delivery plus this cryptographic signature.
Right. So because the smart contract on the receiving ledger Ethereum can check the quorum certificate of the data that was created on your network. Correct. So essentially, it can verify that the consensus was reached on the other network. And because signature verification is not expensive in gas fees, that's not a massively expensive thing to do. Okay.
Well, it's not cheap, I want to mention it depends on the chain.
It's not cheap, but it's not as expensive as it should be. As in, it's one of the few things that is essentially subsidized on all networks because it's so important.